Alright, our next lesson we're going to look at is when we combine functions. So we're going to take two or more separate functions and we're going to put them together by adding, subtracting, multiplying, or dividing. So we'll start with just looking at a simple one being added. So the rule is if you add two functions, so in this case we want to take x squared as one function and minus x plus 5 as the other function. So when we're working with an equation, the simplest way to add them is just to simply put them together. So in this case, our sum of these would be x squared minus x plus 5. So what happens is in terms of our graphs, if we graph these, x squared would look something like that. Minus x plus 5 would look something like that. So if we actually graph our x squared minus x plus 5, we get another quadratic. What happens is we're basically adding the y values. So in this case, if we look at that point of 5, this is 0. We add those together, we would get a point of 5. If we take some other point here, so let's suppose that we look at 1, we'd have a point of 1 for that graph, and we'd have a point of 4 for this one. So 1 plus 4 would give us 5 as well. And if we tried to say negative 1 would be at 1, and on the other graph we'd have negative 1 would be at 6. So 1 plus 6 would give us 7. So what ends up happening is we end up getting, if we add all these coordinates together, the y coordinates, we end up getting another quadratic that would look something like that. So it's pretty simple when you're combining functions, just simply add or subtract, multiply, divide, whatever the case may be. And we can just simply merge the equation that way, and that would give us the graph of the new equation. Or what we can see is we could actually plug in the numbers. So let me go back to the first one here, just to kind of show you an idea. So if the question said what is f plus g of 3, so if we wanted to know what the y coordinate is when we do 3, we could figure out 3 for the individual ones, so 3 squared, and then go plus minus 3 plus 5. If we just take the 3 and put it in both of our original equations, so that'd give us 9 plus 2, which is 11. Or we could put 3 in our new combined equation, and we get the exact same answer. So we get 11 for each. So what that means is at the point x equals 3, our coordinate on the new graph would then be at 11. So it's 9 on one graph, 2 on the other. Add the two together, we end up getting 11. Okay, when we're dealing with graphs, just like before, we can figure out x, y intercepts, domain, range, all that kind of stuff. So the only stipulation, or the only thing that sort of works out with this kind of stuff, is our domain of the new graph will be whatever overlaps between the domains of the original. So if our original graph, in the last case, we had XER for the line, we had XER for the parabola, so therefore the overlap will still be the same. It'll be XER. So the new parabola will still have an unlimited domain. The range is just going to depend on the graph, so you're going to have to graph it and figure it out from that one. So if we look at the last one, that new parabola would drop down to probably 4.5 or something like that. So in that case, our range would be y is greater than 4.5. So there is no pattern or anything for the range. You just have to go from the graph. Okay, so in this case, let's suppose we have a domain greater than 0. So that would be something like, an y or a graph, something like that. So we only have anything greater than 0. And if our second graph was domain is less than 5, then we just do what's common to both. So in this case, our domain would be between 0 and 5. Okay, and then our range, once again, we just would have to figure it out from whatever the graph would show up as. So that's it for adding graphs, and subtracting basically works the exact same way. So in this case, if we have our two functions and we want to subtract them, you just got to be careful. We would get minus 2x, and we're going to subtract x minus 4. Put it in brackets so you don't mess up your signs. We'd have minus 2x minus x plus 4. So we could simplify that to minus 3x plus 4. Okay, and just like we did before, if we were to actually look at the graphs, minus 2x would be a line something like that. X minus 4 would be a line something like that. So therefore, when we combine these, in this case, we'll be subtracting the y values. So we'd have, in this case, we'd have 0 take away -4. So that would give us +4. 0 minus -4 would give us +4. So the new graph is going to be up at 4. And we can put that in here. If we were going to plug in a 0 into this one, you can see it does give us 4 into the equation. So we could do that for any of them, but just like we did for adding, the only thing that's different now is we're going to subtract the y values. So in this case, we'd end up getting a graph something like that. When we do products, same idea again, except now we're going to be multiplying the y coordinates. So if we have x plus 3, and we're going to multiply that by 2x minus 1, we could just leave it like that. We don't need to FOIL it out, but we could if we wanted to. If we really wanted to, we could FOIL this out and get 2x squared plus 5x minus 3. So in this case, these two lines, when we got two positive lines, it would look something like that. So when we put those together, we end up getting some kind of quadratic. So the new graphs aren't going to be as obvious to figure out what they're going to look like. But the idea is we're just multiplying, dividing, whatever the case may be. So for the last one, for dividing, here we're going f divided by g. Take your f equation, divide it by the g equation. And if we wanted to, we could factor, but it doesn't really change anything. So other than with dividing, because now we have something on the bottom, we would get non-permissible. So in this case, we'd say x can't be 0 or 1. Okay? So let's go through a couple examples. We'll look at kind of doing types of questions you'd be expected to do. So these ones are just taking these generic equations and asking you to add or subtract them. So if we're adding them, we'd have x plus 1 plus 2x minus 5. And if we simplify that, we get 3x minus 4. Now if we want to subtract them, we'd have x plus 1 minus, let's put brackets on it, 2x minus 5. So that would change our signs. So we'd have negative x, and 1 plus 5 would be 6. And the last one is just the same thing, but the other way around. So we'd have 2x minus 5, and now we're going to subtract x plus 1. So once again, change our signs. So we'd have 1x minus 6. So quite often when you do the subtractions, you're going to see that our two answers are going to be the same, just our signs get traded the other way around. And you could do another one where they actually ask you what is the y coordinate going to be when you plug in a certain x. So we can do it either way. We could just take it separately and add the two together. So in this case, if we put a 4 into the x squared, we'd have 4 squared. And then we're going to add on root 4. So 4 squared is 16, root 4 is 2. That would give us an answer of 18. Same thing if we subtract. So in this case, we're going to plug a 9 in. So we'd have 9 squared minus root 9. So that gives us 81 minus 3, which gives us 78. And our last one the other way around. So we're going to do root 1 minus 1 squared. So we get 1 minus 1, which would be 0. Okay, let's try a few more, but with multiplying, dividing. So in this case, we've got a multiplication, so we have x minus 3. We're going to times that by x squared minus 8x plus 15. So we could leave it like that, or quite often if you get quadratics and things like that, it's a good idea to maybe factor them. So you could see the factors of this one would be x minus 5 and x minus 3. So we could also write this as x minus 3 squared, because we have two of them, and x minus 5 would be the simplest way to write that one. If we're dividing, so in this case we have x minus 3, and let's write it as the factored form. So we have x minus 5, x minus 3. So you can see in this case our x minus 3's would cancel. So that'd be the same thing as 1 over x minus 5. But remember with dividing, we've got to make sure x doesn't equal 5 or 3. And our last one would just be the other way around. So we'd have our quadratic on the top, x minus 3 on the bottom. In this case it would cancel, so we just get x minus 5. And in this case, x can't equal 3. Okay, and just like we did with the last one, we could do the same thing where we actually plug in numbers. So f times g, so we put in 2 for the f, so we have 2 minus 1. And we're going to multiply that by 2 squared. So that gives us 1 times 4, which would be 4. If we do a division, we have negative 3 minus 1 for the first one, negative 3 squared. So that would give us negative 4 over 9. And if we do it the other way around, we'd have 1 squared over 1 minus 1, which would give us 1 over 0, which is undefined. We can't divide by 0, and the reason for that is a 1 is our non-permissible value on the bottom, so we can't in this case. So when we did letter B, x squared was on the bottom, so we just had x can't be 0, which was okay because we're doing negative 3. But in this case, it's undefined because x can't equal 1. And that's it for adding, subtracting, multiplying, dividing. Pretty simple stuff. Just add or subtract the functions, whatever they ask. Sometimes you need to plug a number in, and that's all.